We'll be asking some questions to EQ2 from the chapter Unit 04, Work, Energy, and Power. To proceed, please select the Unit 04, Work, Energy, and Power chapter from the list above. Question: list all the topics. The topics covered in the chapter Work, Energy and Power from the CBSE 11th standard as per NEET Physics syllabus include work done by a constant force and a variable force, kinetic energy and potential energy, work energy theorem, power potential energy of a spring, conservation of mechanical energy, conservative and non-conservative forces, motion in a vertical circle, elastic and inelastic collisions in 1 and 2 dimensions. If you have any specific questions about these topics, feel free to ask. Let's ask EQ2 to explain the first topic, work done by a constant force and a variable force. Question: explain me work done by a constant force and a variable force topic. Answer: certainly. Let's break down the topic of work done by a constant force and a variable force. Let's discuss for work done by a constant force. 1. Definition of work. Work is defined as the product of the force applied to an object and the displacement of that object in the direction of the force. Mathematically, it can be expressed as below formula, where W equals work done, F equals magnitude of the force applied, D equals displacement of the object, theta equals angle between the force and the displacement vector. 2. Special cases. If theta equals 0 degree, force is in the direction of displacement, then cos 0 degree equals and W equals F dot D. If theta equals 90 degree, force is perpendicular to the displacement, then cos 90 degree equals 0 and W equals 0. Now, let's discuss for work done by a variable force. 1. Definition: when the force acting on an object varies with displacement, we cannot use the simple formula directly. Instead, we determine the work done by integrating the force over the displacement. 2. Mathematical expression: the work done by a variable force Fx as the object moves from point A to point B can be expressed as below formula. Here, Fx is a function of position. 3. Example: consider a scenario where the force acting on an object varies linearly with displacement, such as a spring, Hooke's law. The force exerted by a spring is given by F equals minus kx, where k is the spring constant and x is the displacement from the equilibrium position. To find the work done in compressing or stretching the spring from position x1 to x2 as seen in below formula. 4. Graphical interpretation: the work done can also be represented graphically as the area under the force versus displacement graph. If you plot force on the y-axis and displacement on the x-axis, the area under the curve represents the work done. Summary: for a constant force, you can use the straightforward equation W equals F D plus theta. For a variable force, you need to use integration to calculate the work done, considering how the force changes with displacement. Understanding these concepts helps in analyzing various physical situations involving forces and motion. If you have further questions, feel free to ask. I have a question. A cyclist comes to a skidding stop in 10 meters. During this process, the force on the cycle due to the road is 200 N and is directly opposed to the motion. A. How much work does the road do on the cycle? B. How much work does the cycle do on the road? Answer: let's analyze the problem step by step. Given data, distance skidded, D equals 10 meter force opposing motion, friction force, F equals 200 Newton. The force is directly opposed to the motion of the cycle. A. Work done by the road on the cycle. The work done by the road on the cycle is given by the formula W equals F dot D dot cosine theta. Since the force exerted by the road, friction, is opposing the direction of motion, the angle theta between the force and the direction of displacement is 180 degree. Thus, the cosine term becomes cosine 180 degree equals minus 1. Substituting the values, W equals 200.10. Minus 1. W equals minus 2000 joule. Conclusion for A. The work done by the road on the cycle is minus 2000 joule. This negative sign indicates that the work is done against the motion, leading to a loss of kinetic energy. B. Work done by the cycle on the road. According to Newton's third law, the force that the cycle exerts on the road is equal in magnitude and opposite in direction to the force that the road exerts on the cycle. Hence, the force exerted by the cycle on the road is also 200 Newton, but in the direction of motion. When calculating the work done by the cycle on the road, the angle is 0 degree because they act in the same direction, so W equals F dot D dot cosine 0 degree. Cosine 0 degree equals 1. Substituting the values. W equals 200.10.1. W equals 2000 joule. Conclusion for B. The work done by the cycle on the road is 2000 joule. This work is positive, indicating that energy is being transferred from the cycle to the road. Summary. Work done by the road on the cycle, minus 2000 joule. Work done by the cycle on the road, 2000 joule. If you have more questions or need further clarification, feel free to ask. Let's ask another question. Please provide me some more examples for work done by a constant force and a variable force topic. Enjoy the answer provided by EQ2 below. One question is deducted for every 1000 completion tokens.